Hello everyone. So in today's video, I will be explaining two of the key concepts of ATOMSK. Um, so jumping right into the video, the first topic which I would be discussing is file conversion, and the second topic which I would be discussing is interpolation of configurations. So in the first topic, file conversion. So what does file conversion mean? So suppose you have a list of files which ends with the extension XYZ, and you want to convert all of those files ending with the extension XYZ to CFG format. So if you try to use this star.xyz, and if you try to convert your XYZ files into CFG in this format, it will not work. The main reason is that ATOMSK will break down the first code into the second line of code you see here. So it will break down into, for example, if you have 6 files containing XYZ, for example mdo.xyz, md1.xyz, it will break down your initial code into the second line of code. And what the second line of code means is that the mdo.xyz will be converted into md1.xyz. So this is not something that you wanted initially. What you wanted was to convert a lot of files into a different format. So for this, what you need to do is you need to generate a list. In this code you will see that ls. So ls is the terminology we use to generate or create a list, and star.xyz means all of the files ending with the extension xyz would be stored in a file or in a text file named myfiles.lst. Now if you call that file, and then you can easily convert into CFG, and in this way you can convert all of the files into the CFG format. Now in a case if you want to ignore some of the files which has already been converted, there is also an option atomsk. You are calling the list again, and you see at the end you are using ignore. So by this ignore, the atomsk will automatically ignore all of the files that has already been converted. The next topic which I would be discussing is the interpolation of configuration. So as you can see in this slide here, there are 4 atoms, and in the third space there is no atom, and at the end you see there are 4 spaces, and at the second space there is no atom. So what I'm trying to say is that there are 2 configurations, and in the first configuration the vacant position is the third space, and in the last configuration the vacant position is in the second space. So in different cases you might need to work with vacant spaces, or how atoms move within the vacant spaces, and in such cases configuration interpolation will help you. So you see you have an initial configuration, and you will define the final configuration. Then what you can do is you can generate a random number of intermediate configurations which you can set by code. So I will show you the code now. So as you can see at the first line here, I am generating a FCC structure composed of aluminum atoms of lattice parameter 4.02, and I am duplicating it along all the axes by a multiple of 10. Then what I am doing is I am removing the first atom, and I am storing the whole structure in a .cfg file format. So this is my initial structure, and in the same way I am generating a final structure where I am removing the second atom of the whole structure. So what I will do in the next step is I will generate a number of interpolation configurations. So as you can see, this dash dash interpolate, which means that it will generate some configurations which is in between the initial and final configurations. And as you can see the number 7 here, so the number 7 is the number of configuration which is in between the initial and final configuration. So as you can see now you have a total of 9 configuration: the initial, the 7 interpolations, and the final configuration. So here is a visual of how this will help you. So as you can see, the black ball which is moving, it is basically showing you how the atom moves in the vacant space. So why is this interpolation important? So the first thing is chain of state calculations. So if you go to the previous slide, you see that here the black sphere moves in a straight line from this position to this position. So it is a very easily determinable situation because you are looking at it from a two-dimensional point of view. But if it was in a complex configuration of a three-dimensional geometry, it would not have been so simple. So in that case, if we find out the interpolation configurations, it would be easier for us to understand how atoms will move, because atoms always moves through the positions of the least energy. From this, you can also use the nudged elastic band method. So what is this nudged elastic band method? So this is a method which helps us find the different states of the lowest energy possible. So as you can see, through interpolation we can find out those configurations, and if we can find out those configurations, we can also find out the energy at that particular state. In this way we can find out the lowest possible energy route for the atoms to move. We can also understand how defect moves in a particular structure. So this will help us understand how defect moves and what are the lowest possible energy states in case of the movements. So these are the two topics for today. I hope you have understood it. Thank you.